In this episode, we're going to look at how to back up configuration files. I'll show you how to do it, and we'll talk about the ideas along the way. We will restore a configuration file from backup and then perform a new backup. Due to an equipment failure, a new router has been put in place. Fortunately, backup configuration files have been saved to a trivial file transfer protocol or TFTP server. We are required to restore the files from the TFTP server to get the router back online as quickly as possible. We'll be discussing establishing connectivity to a TFTP server, transferring the configuration file from the TFTP server, and then backing up configuration and iOS to the TFTP server. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 10.6.10 Backup Configuration Files. I have the Packet Tracer file open. On the left side, I have our work area where we have our topology and we can work with those devices. On the right side, I have our instructions. The very bottom right is the Packet Tracer activity window that opens up when you open up the Packet Tracer file. On the upper right, the majority of the right side, is a Word document containing those exact same instructions. The reason I have those exact same instructions in a Word document, we have some questions to answer. This will allow me to put my answers in there and save them. Our objectives: we're going to establish connectivity to a TFTP server, transfer the configuration file, and then back up the configuration and iOS to the TFTP server. Part 1, establish connectivity to the TFTP server. Because this is a new router, so RTA here, router A, is a new router, initial configuration will be performed using a console connection to the router. So we're going to use this blue console connection to configure our router. Click on PCA, then the desktop tab, followed by the terminal to access router A command line. I'm going to click on PCA. Then, and bring this up, I make this a little bit wider. Then I look for our terminal app. Right here, top row center, this is our terminal app. Take the default numbers, but it is good to know this, 9600 8N1N. And we are connected into our device. We can hit enter. This is just like we were at our router. First thing here, let's go ahead and type enable. Brings us in. We are now into privilege exec mode. Make it a little bit more wider. Step 1B, configure and activate the gig00 interface. The IP address should match the default gateway for the TFTP server. So it should match the default gateway for the TFTP server. Well, we need to get that address. What we're looking at is configuring this interface, but we have to get the default gateway off of our TFTP server. I'm going to click on our TFTP server, slide this over, click on our desktop tab, click on IP configuration. Here's our default gateway. I'm going to go ahead, write that down, 172.16.1.1. Then we can go over and set that interface. Now, how do we know which interface this is? Well, I'm going to click in this white area, make sure this window's activated. Then I'm going to mouse over, because we're on our router A here, and I'm going to mouse over this connection. This is the one we're looking for. So we're going to configure gig00 to that IP address of 172.16.1.1. To do that, we have to first go into global configuration mode, so config T. Then we have to go into that interface. So interface, and that was gig0/0. You can tell our prompt has changed. We are now configuring an interface, and we have to set that IP address. So it's IP space address space, and then our IP address 172.16.1.1, and that was a class C address, so it's 255.255.255.0. If you don't remember that, go back and look at the IP address back on the server in the IP configuration app on the desktop. That was our Class C address there. And last thing to do is do a no shutdown on it. So go ahead and type in no shutdown. Brings it up and up. We should be ready to go. The IP address should match the default gateway. Part 1. Step C, test connectivity to TFTP server. So let's go ahead and ping our TFTP server. Our TFTP server address is, didn't tell us. Let's go back into our configuration. I clicked on TFTP server and I'm on desktop on IP configuration. Once again, here is that subnet mask. Our IP address is 172.16.1.2. The default gateway was .1.1 at the end. The IP address of our server is 1.2, 172.16.1.2. Back here on PCA, let's go ahead and ping our server, 172.16.1.2. Cisco was kind enough to tell us that we have something wrong. What did I forget? I forgot the word ping. So ping space 172.16.1.2. And of course, Cisco is reminding me I can't do this in an interface configuration mode. Type exit once for global configuration, exit twice for privilege exec mode. Now I can go ahead and ping the server. So ping 172.16.1.2. First one failed, had to do an ARP lookup. The other 4 worked. I'm going to repeat that command. Up arrow once, hit enter. All 5 work. So now our RTA1, or sorry, router A can ping TFTP server. We have connectivity there. So that takes care of part 1. On to part 2. Transfer the configuration file from the TFTP server. What we're going to do is there's a configuration file here on the TFTP server. We're going to copy that from there and put it into our running configuration on router A. So we're going to take the saved configuration from the TFTP server, copy it into our RAM, copy it into our running configuration. Something to notice here. Notice how the connection between router A and switch 2 is down. I have a feeling if we copy in our configuration, it might go back up. But notice how they are down right now. It's supposed to be down. On to part 2. Transfer the configuration file from the TFTP server. From privilege exec mode, once again, we are on router. On the router, issue the following command. Once again, pay attention. This connection is down on our diagram. I have a feeling that's going to go up. Also notice the name of our device. The name of our device is called router. When we copy this configuration in, I have a feeling those items will change. Okay, to copy it from the TFTP server to our running config, we hit, our command is copy space TFTP and then running dash config. Address or name of the remote host. Our TFTP server address is 172.16.1.2. Then it's going to ask us for the source file name. That's the name of the file on the server. Somebody previously already saved the configuration to that server and they called it, and we have to put the name in here, capital R, capital T, capital A, dash CONFG. Now there's no I in that name, so it's CONFG. That's the name of the file. And then it's going to confirm that we want to copy it to the running config. Yep, that's right. All you have to do is hit enter. Tells us that we are accessing the TFTP server. We loaded our file rta.cn TFG from the TFTP server 172.16.1.2. We copied 785 bytes in 0.001 seconds. And then we also get a system update configured by console. Notice what changed. We are now at RTA is the prompt of our device. We were at router, now we're at RTA. Issued the command to display the current configuration. Well, before we do that, I'm going to slide this over. Oh, this is still down here, so maybe we have to look into that. But we see that we now have, our name has changed. Once again, we're going to display the current configuration. So that's a show running -config. Here's our configuration. Once again, here's our host name specified as RTA. Loads in some other configuration. So what changes were made? Configuration was stored on TFTP server and was loaded into the router. Into the router, and host name was set to RTA. There's configuration. Issued the appropriate show command to display the interface statistics. Well, I'm going to go ahead, enter in show IP interface brief, and it's going to list out our connections. Gig 00 is the connection to our TFTP server. That's up. But then our other connection, Gig 01, it has an IP address of 172.13.1.1, is administratively down. Are all the interfaces active? No, they're not. So no. And then G01 is administratively down. Correct any issues related to the interface problems and test connectivity between PCA and the TFTP server. Well, if it's administratively down, odds are it's shut down. Quick way to look at that is our running config. Let's do a show run again. Here's our interface for Gig 01. We have our IP address, duplex speed, and it is shut down. We need to go into the Gig 01 interface and do a no shutdown on it. I'm going to do a Control C, breaks us out of the show run. Config T, global configuration mode, interface Gig 0/1, and no shutdown. Interface is up. Gig is up. Let's go ahead. Type exit once, exit twice, brings us back to privilege exec mode, and do a show IP interface brief. And now both of our gig interfaces are up. That's what we're looking for. Part 3, back. Oh, sorry, we're not there yet. Correct any issues. Test connectivity between PCA and the TFTP server. Between PCA. So now, instead of the terminal is actually connected to RT1. What we need to do is go on PCA, not in the terminal, but in the command prompt. So I'm going to close our terminal. Up here where it says terminal, this blue line, the right side, there's an X. Go ahead and click on that. Then I'm going to open up the command prompt app here. Go ahead and click on the command prompt app. Now we can ping the server. So ping. And then that IP address again was 172.16.1.2. And Windows now from the command prompt is pinging that. We sent out 4 echo requests. We got 4 replies back. We have successful connectivity. Part 3, backup configuration in iOS to the TFTP server. Change the host name to RTA. Change the host name from RTA to RTA-1. Okay, let's go ahead and do that. That is, we go into Once again, we're in the command prompt on the PC. We need to be in the terminal. So I'm going to go ahead and close the command prompt, open up my terminal. Here in my terminal, take the default settings for your port configuration. And we're right back where we were. Change the host name. So global configuration mode, config T, and then host name. And we want the host name of, what was it again? Capital R, capital T, capital A, -1. Now we can see our host name has changed. Save the configuration to NVRAM. Exit out once. Two ways of doing that. You could use the write memory command, and I'll write the memory to NVRAM, or copy running -config space start, or copy run start. Destination file name, startup config. Yep, that's what we want. So go ahead and hit enter, and it's going to copy that information over for us. That was step 3B. On to step 3C. Copy the configuration to the TFTP server using the command. Or using the copy command. From R1 here, or RTA1 now, we changed the name of it. We have to copy, and once again, the copy command works. You put the word copy, where are you copying from? So that's going to be our running config, and then we're copying, where are we copying to? We're copying to the TFTP server. So we start out with copy, and then our running -config. Then we're copying it to the TFTP server. So TFTP, and then you have to put a colon at the end. It's going to ask you, what is the address of our TFTP server? Once again, that is 172.16.1.2. And it's going to ask you, what is this, what you want to call it? What it's going to give you is RTA-1. That is the name of our device, what we changed it to. And then it's going to put the -CONFG on the end. Once again, there's no I in it, so CONFG. Is that what we want to call it? Yep, that looks pretty good. Let's go ahead, hit enter. And it's writing the configuration. It copied it there. We successfully did that. Issued the command to display files in Flash. We can just type in dir, gives us a directory of it. Here's the directory. It says we're in Flash. This is our information we have. These are the 3 files. This is our iOS. This is our Cisco iOS file here. C1900 Universal KM MZ SPA 151.4M4.bin. What we're going to do is we're now going to back up the iOS. So we're going to back up this file to the TFTP server. We are going to use the copy command again. So it's copy. And then where are we copying from? So we're copying from Flash. And we're copying to TFTP. So TFTP, and then we have to put that colon at the end of TFTP. It's going to ask us to, what is the file name? So in our Flash, because that's where we're copying from, what is the name of the file? This is the name of the file. What I'm going to do here is I'm going to highlight the file name from the beginning C all the way to the .bin at the end. I'm going to make sure and highlight my entire name from the C all the way to the bin. I'm going to right click on it and say copy. Come down here to where we're supposed to put our source file name. Right click and put paste. That puts that name in there. Or you could go and manually type that if you wanted. I prefer to do a copy and paste. Once you have that in there, go ahead and hit enter. It's going to ask you for the address or name of your TFTP server. Where are we going? We are going to 172.16.1.2. We're going to confirm this is what we want to call it. Well, that's what we have it saved in Flash. Why not call that the same name on TFTP server? If that's what you want. Go ahead and hit enter. That's what I'm going to do. And notice we are writing this file. The name wrapped, so it started with the C, ended with the bin. And then we are writing this information, all these exclamation points. Every time it writes so much data, it gave us another exclamation point. When we copied our configuration over, we only got 2 exclamation points. It's a very small file compared to the operating system. Operating system, really big, gave us a lot of lines of text. What special character repeatedly displays indicating the iOS is being copied to the TFTP server? It is the exclamation mark. The exclamation mark, exclamation point. So I'm going to put that there, which is, and I'm just going to type it out, exclamation point. Part 3F, open TFTP server. Click on the TFTP services tab, select TFTP, scroll through the iOS files. Okay, so over here on the TFTP server, I'm going to click on that. I'm going to close our IP configuration. Clicking on the X on the right side, the blue line. Over here, I'm going to click on the services tab. Then I'm going to click on TFTP, and it's going to list out all of our files. Has the iOS file, starting with a C, ending with the .bin, been copied to the TFTP server? Looking here, we are looking for the C1900. Well, there's a couple of them. And our numbers in the center, this is the important part that we need to look for, 151-4. Here is the 151-4. Our file was copied to the TFTP server. We can also see that our new config we copied there, RTA-1, that's the new name of our device, that was also copied to the TFTP server. So getting back to our question, has the iOS file been copied to the TFTP server? Yes, it has. So yes. That was Packet Tracer Lab 10.6.10 backup configuration files. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.